All right, guys, continuing on from visual illusions last lesson, today we are looking at the Ames room illusion. So it's named after Albert Ames, who intentionally designed the room to distort visual perception. It involves people appearing smaller or larger depending on where they are standing in the room. So why does this occur? It's to do with the shape of the room, restriction of vision. So you can see here, this room is designed so that when you are standing on the left side of the room, you look very tiny. Whereas when you stand on the right side of the room, you look very tall. You can think of it like Alice in Wonderland when she has the tea and biscuits. So depending on where you stand in the room, changes how large you look. If you have a watch of these YouTube clips, you can actually see how you can move right across the room and how that changes. So what's going on here? The Ames room illusion is because the shape of the room is actually not a normal shape. It's trapezium shaped. And you can see here. So this is the back left-hand corner if we're looking at it from a bird's eye point of view. And this is the back right-hand corner. And you're viewing the room from here. So to you, when you're looking through your little peephole, because it's a peephole access to the room, we'll see it as a square or rectangle, because that's what our perceptual set is, that what rooms are. They are generally squares or rectangles. Now on top of that, there's a higher ceiling on the left-hand side here than on the right. So it actually has a ceiling that slants down towards the ground. And the back wall is slanted away from the observer. So as you can see here from a bird's eye point of view, the back wall slants away from you. So you're actually further away from the viewer on the left than you are on the right. And we can see that in these images a bit more here. So this is what you think you're seeing. But in actual fact, the left-hand corner of the room is way back here. Now, this occurs because we have a restricted vision. So the room is only viewed through a peephole. And because it's a peephole, you have monocular vision. Only one eye can view the room. So you can't use binocular cues to determine what's going on, only monocular cues. That's another example of what the room looks like. And our past experience, as I said earlier, with rectangular rooms leads us to expect that people in the room are always the same distance away from us. So we're used to rectangular rooms, so we assume that this person here is the same distance away as this person here, but that is not the case. Instead, this person here is going to cast a smaller image on our retina, and this person here is going to cast a larger image on our retina because of the distance they are from us. Because we expect them to be the same distance away, this person therefore appears smaller. So apparent distance theory is when two retinal images are the same size, but one image appears to be further away than that image that will be interpreted as further away. Gosh, that sounds confusing. So two retinal images, this person here and this person here. So apparent distance theory is one image appears to be further away than that image will be interpreted as further away. So because apparently these are the same distance, we don't interpret them as being further away here. We interpret them as being the same distance. So have a look at this image here. When we apply apparent distance theory, we assume that this person is further away than this person. Now, when you actually have a look and measure this out, and you can just get your hand on the TV, on your screen here, you can see these images are actually the same size if you measure them with a finger or a ruler. But because this person appears to be further away due to our background cues, this person therefore is going to be interpreted as larger. Right, unfortunately we don't get to do this activity because we are doing remote learning. So you're going to do textbook activity 8.1, questions 1 to 6 ideally, but have a look at Compass for the minimum requirements, and then the logbook activity on the Ames room illusion. I will also upload the cut and paste activity from before. If you've got time and you're just sick of the screen and writing, you can have a go at creating your own Ames room. Okay.